Hey, remember this clip from Ant-Man 2? I will be explaining you the working of this thing. Let's begin with the basics. This is atom. Must be familiar with it. It is a known fact that atom is an uncharged species. For our experiment, we need charged one. So, we pick up proton in form of H positive. Get ready for an experiment, H positive. Don't you be scared. It's all right. Be a man, put on a smile, and let's go. Here in this room, as soon as we close the switch, electric field is set up in this direction. Here comes H positive with initial 0 velocity. Whoa, we can see it accelerating, and for acceleration, it definitely needs force. From electric force formula, we get F is equal to QE. Substituting F to be, MA is equal to QE, where A is equal to QE upon M is the magnitude of the acceleration of H positive with the same direction as that of the field. Having attained considerable velocity, H positive enters magnetic field realm. The field lines are going into the plane of the paper. The field exerts force on H positive in a perpendicular direction given by Fleming's left-hand rule. The magnetic force here acts as a centripetal force and is responsible for the circular motion. As it acts in a perpendicular direction, it cannot interact with the transverse velocity of the H positive. This causes its motion to be circular one with a constant velocity. So now we have learned something about H positive, huh? Having all this known, a great dude from America, Ernest Lawrence, decided to place H positive in an apparatus known as cyclotron, aka particle accelerator, whose setup is as follows. Two D-shaped metal chambers, namely D1 and D2, are placed with a slight separation between them. These Ds are connected to a high-frequency oscillator which can produce the potential difference of the order 10 to the power 4 volts at a frequency of 10 to the power 7 hertz. This apparatus is well insulated and placed in a strong magnetic field. There is a small window in D1 for H positive to come out. This is apparatus top view. Here magnetic field lines are going into the plane. At any instant, say D1 is at negative and D2 is at positive potential. Hence, the electric field directs in this direction. So does the acceleration for H positive. On reaching inside of D2, it enters in an electric field free space. The only presence of magnetic field causes us to move in a circle, that too with a constant velocity. From the formulas, we can calculate radius of the path as in one go. H positive only covers a semicircle. We use T is equal to pi r upon V to calculate the corresponding time. We obtain T to be pi m upon bq. As all the entities here are constant, we deduce that T is constant. This reduces our effort a lot. We find a particular AC source that oscillates and reverses its polarity in the given time, making D1 to be positive and D2 to be negative, which further reverses the direction of the electric field and hence the acceleration. Again, for a very small time, it speeds up and enters the magnetic field. And the process continues until the desired value of speed is achieved. As we can see, the radius of the path increases, so does the velocity. The significance of a slight separation is that in this area, only strong electric field exists that dominates the magnetic field. If it would have been otherwise, we would have noticed presence of both the fields. Now H positive has been long in there, huh? So let's say it has achieved the value as high as flash. And now it is ready to rock. Boom!
Maximum power.